Hi, Assalamualaikum. My name is Nur Ain Mardia binti Muayyusri in a group of 4L, and today I'm going to do a presentation about one of the process for lab 2 milling operations. Okay, so this is the question that I received for this lab milling. For the next slides, I will show you guys a video of me doing one of the machining process for this milling operation, which is rough mill rectangular pocket inside, which also the fourth process of this milling operations. Okay, so based on that video earlier that I showed, I will explain to you one by one of how I got the answer. I will explain to you the fourth process of this milling operation, which is rough mill rectangular pocket insides. So that's answer for the part A of this machining process. And then we go to the part B, which include cutting tool, description of that, number of inserts, size DC dimension, also LF and LH dimensions. So for this process, we use cutting tool of mu and mil. And also for description, also how to know the description, we have to know first the size DC dimension of the block that this process is used. So the reason why I got 50 is because I took the horizontal dimension of the block of this process used, which is 100, and I divided by 2, then I got 50. And then that 50 millimeter, I see if there are any size of 50 millimeter in the appendix. And as you can see, there is the last one, which is also include the number of, so if you get that 50, they include the number of insert of 5, and then the LH and LH dimension of 100 millimeter and also 50 millimeter. So technically, the description of this cutting tool that I got is 50S3210-5T. Okay, so we're gonna go to the part C of this process, which include cutter material, cutting speed, and mill diameter, machine maximum, cutting edges, spindle speed, chip load, and also feed rate, and also lastly estimated time. So for all of this part C, we're going to calculate it by using this website that I attached in this presentation, and also I showed it earlier in the video. So for the material of this milling operation is going to be carbide, except the process of drill. So this is the process of milling, so the cutting material is obviously going to be carbide. And then we're going to put that into the website, which is Clay 8111, which is millimeter, and operation is going to be milling, material is going to be aluminum, and cutting material is going to be carbide. And immediately it will show you the cutting speed of this going to be 2074 per minute. And also we're going to put the end mill diameter, as I said earlier in the part B, is going to be 50 millimeter. And also the machine maximum is, as usual, is gonna be 6,000, and also included in part B, the cutting edges is gonna be 5. So after we fill out all of this, then we're gonna click calculate, and it immediately show the value for spindle speed, chip load, and also feed rate. So for the spindle speed, it's gonna be 1740, and then for the chip load it's gonna be 0.4, and lastly for the feed rate it's gonna be 3489. So that's done. So let's go to the estimated time for this process. So how to calculate this is by using length of cut divided by feed rate that I got earlier. So the length of cut is gonna be 100 millimeter divided by feed rate that I get earlier, which is 3489 millimeter per minute. So after we calculate it, the estimate time is gonna be 0.029 minute. Okay, that's done for part C. And then we go to the part D, which is the graphic illusion that I sketched myself for this process, which is a rough mill rectangular pocket inside. So you can see the sketching over here. Okay, that's all from me. Thank you so much for listening.